This paper suggests that the catastrophic disintegration of the Larsen Ice Shelf in 2002 was associated with changes in the atmospheric temperature rather than ocean temperature. Such disintegration proved that ice sheets can change on societally relevant timescales, with atmospheric warming as a clear trigger. Researchers from US, Italy, Portugal, Germany, Canada and UK collected marine data in 2005 and 2006 on board the United States research icebreaker Palmer. This study focused on grounding zone systems where ice sheet transition between grounded and floating ice helps regulate ice flow. Understanding the dynamic of grounding zones is becoming increasingly important to projecting future sea level rise from ocean terminating glaciers. There are two scenarios for ice sheet demise and consequent sea level rise. One, under melt by warm ocean currents and thinning at the bottom of floating ice shelves. And two, surface warming and instability of ice shelves. In the under melt idea, grounding line retreat is induced as thinner ice cannot remain grounded in deep water. So, one way to test which mechanism was operating in the Larsen Ice Shelf was to study grounding zones, which normally are very difficult to assess. Exposure of the seafloor by the Larsen Ice Shelf collapse in 2002 allowed detailed morphologic mapping and sampling of the formerly covered embayment. Data reveal a large, arcuate, complex grounding zones at the front of the Crane Fjord, which once was filled with ice. Radiocarbon constraint chronologies from marine sediment cores indicate loss of ice contact with the bed at this site at about 12,000 years ago. The Crane Glacier grounding zones was hence landward, well within the fjord prior to 2002, and did not retreat further until after that ice sheet collapse. This implies that the 2000 Larsen Ice Shelf collapse was likely a response of surface warming rather than to grounding zone instability. As estimates for projected sea level rise over the next centuries continue to be revised, the stability of grounding zones needs further evaluation. The stability of Larsen Ice Shelf to the Holocene and its rapid collapse suggests strong sensitivity to surface warming. This adds to the scenario of instability now facing Antarctic glacial masses and must invigorate continued examination of grounding zones, in spite of difficulty in assess, logistical risk and competing resources.